Patty Simpson with Simpson Math. In this video, we're going to add and subtract integers. Now, all an integer is just a whole number that can be positive or negative. So we're just going to add those positive and negative numbers. And we're going to use a number line to help us in the beginning. So let's start with an example here of -7 plus 5. And I'm going to use a number line to help me with this addition. So on the number line, I'm going to start at this first number. Notice in that first number, I'm in negative land. I'm at -7. Then this positive tells me I'm going to move towards positive land. I'm going to walk towards that positive. So I'm going to move to the right 5 spots. So I move over 5 spots. 1, 2, 3, 4, 5. So I've added 5. And I'm just going to find out where I am at this point. So -6, -5, -4, -3, -2. We ended up at -2. So I started in negative land. I tried to walk to positive land. I didn't quite make it there, though. It wasn't enough steps to make it into positive land. I'm still at -2. Let's do another example. How about if I have a -6 plus 10? I'm going to do that same thing where I start at -6 on my number line. And I'm going to walk towards positive land. So I'm going to start there at -6 and I'm going to walk up to the right 10 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. And let's see where I am. -5, -4, -3, -2, -1, 0. Hey, this time I made it to positive land. 1, 2, 3, 4. So I'm sitting at 4. So -6 plus 10 is equal to 4. In both cases, notice that I started in negative land and I walked to the right towards positive land. Here I didn't make it, there I did. Really though, if you look at these two numbers, the 7 and the 5, what we really did with those two numbers is we subtracted. I took 7 minus 5 and got 2, but because 7 was larger than 5, I kept the sign of the larger number. The same was true here. Really what I did was I subtracted that, this 10 minus those 6, and it gave me the 4. But this time, because 10 was larger, I ended up in positive land. I kept the sign of this larger number. Let me do some more examples where their signs are different. This time, I'm going to do the example of 8 minus 11. I'm going to use my number line again. I'm going to do that same idea where I start at my 8. So I'm going to start at the number 8. And this time I'm going to go towards negative land. So that minus here says to go to the left. So this time I'm actually in positive land, but the negative says to go towards the left. So I'm going to go towards the left 11 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I went backwards 11 spots. And so now I just count down to see where I am. 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, -1, -2, -3. So I ended up at -3. So 8 minus 11 is a -3. Notice again, really all I'm doing is subtracting those two numbers. 11 minus 8 is 3. But because 11 was bigger, I ended up in negative land. I keep this sign of the bigger number. Let's do one more example here. How about if I have 9 minus 5? Now, hopefully you already know that 9 minus 5. This lesson sometimes messes my students up. That before we start, they can do 9 minus 5. And then after this, they're like, I don't know what that is. I have to draw the number line. That's okay. Let's draw that number line to find out. I start at 9. and I'm going to go to the left 5 spots, or towards negative land 5 spots. 1, 2, 3, 4, 5. And I'm going to count down. 8, 7, 6, 5, 4. Notice I'm still in positive land. So all I did there was subtract. 9 minus 5, of course, is 4. We know that. But it's that same rule that when their signs are different, notice this is a positive and that's a negative. This one's a positive and that's a negative. When their signs are different, we're really just subtracting, and then we keep the sign of the larger number. So in this case, the larger number was 9. He was positive, so we stayed in positive land. Our answer is positive. So we can kind of follow this rule as we're adding and subtracting with integers. You can always just use the number line. Drawing the number line is a great way to just solve these problems. But eventually you'll see the pattern that when the signs are different, we simply subtract. Then keep the sign of the larger number. And I put larger in quotes because really 8 is larger than negative 11, but 11 is bigger than 8. So that's what I mean by larger number. Well, what happens when the signs aren't different? What happens if the signs are the same? So let's look at that. And again, I'm just going to use the number line. You can just use the number line over and over and over again until you get really, really good at it. And that's okay. So take, for example, a negative 2 minus 5. So that this time my signs are the same. They're both negative instead of one being negative and one being positive. I'm going to do that same thing where I start at a negative 5. A negative 2. I start at a negative 2. But this time I'm going further in the negative land. So I'm going to go to the left 5 more. 1, 2, 3, 4, 5. Notice I'm walking further into negative land. So negative 3, negative 4, negative 5, negative 6, negative 7 is where I ended up. Look this time. Did I subtract those numbers? No. I added the 2 numbers, but I kept their sign. Let's do another example of that. How about if I have a negative 5 minus 1? So again, both of these numbers are negative. Negative and a negative. So what happens when I have that negative and a negative? Well, I start off in negative land at negative 5. And I'm going to move further in the negative land. I'm going to go to the left 1 spot. That didn't get me out of negative land. I went further into negative land. So really what I did was I added those 2 numbers, but I kept the sign. By the way, in both of these problems, we could rewrite these problems as negative 2 plus a negative 5. This means the same thing as that, because when we have this positive and this negative together, the negative sign wins out. When we do multiplication with integers, we'll see that a positive times a negative makes a negative. So when you see these 2 signs together, the negative wins. Negativity always wins. Don't let it. And the same thing's true here, that I could rewrite this as with a plus sign in between. That negative wins out. This means that their signs are the same. That's the same thing as saying that. Those 2 things are the same. All right, well, what about if they're both positive? What happens in that case? We saw that they're both negative, but what about if they're both positive? So say we have a 5 plus a 3. Well, we know what 5 plus 3 is, right? You know that that's 8. But why does it work the way it does? We'll look at on the number line. You're in positive land to start with. That 5 is already in positive land. And now you're going further into positive land up 3 spots. 1, 2, 3 to the right. So 6, 7, 8. So I end up with 8. We kind of already knew that that was going to be the answer. So when the signs are the same, when they're both negative, or when they're both positive, then we add the two numbers and we keep their sign. So when the signs are the same, we add the numbers and keep the sign of the numbers. Because if I'm in positive land, I move further to positive land, I'm still in positive land. If I'm in negative land and I move further into negative land, I'm still in negative land. So when the signs are different, we're going to subtract and then keep the sign of the larger number. When the signs are the same, we're going to add and we're going to keep the sign of the numbers. So let's put that rule into practice instead of using the number line. Let's see if we can put the rule into practice to do a couple of examples. So here I have 9 minus 12 plus 4. I'm going to take this in pieces. I'm just going to do the first part first, 9 minus 12. So I'm just going to move from left to right. 9 minus 12. Well, when I look at those, the signs are different. This one's positive and that one's negative. So I'm really subtracting. 12 minus 9 gives me 3. And then I'm going to look to see which one is the larger number. Which one of those is larger? Well, 12 is bigger than 9. So I started in positive land, but because this one was bigger, I ended in negative land. So because 12 is bigger, I'm a negative 3. And then I just write down the plus 4. Again, my signs are different. Since my signs are different, I'm going to subtract. 4 minus 3 is 1. But this time, my 4 is the larger number. And so that positive, I actually walked into positive land. So I end up with a positive number. I could also rewrite this as long as I keep my signs together. In other words, this is a positive 9. As long as I leave him positive, I can move him around. See this positive 4? As long as I leave him positive, I can move him around. And this minus 12, as long as I leave it negative, I can move it around. So these two expressions are the same. So now, well, let's do this problem. 9 plus 4. In this case, my signs are the same. Since my signs are the same, I can just simply add those two numbers. 9 plus 4 is 13, and I keep their positive sign. 13 minus 12, now their signs are different, so I'm going to subtract them, and I'm going to keep the sign of the larger number. Notice that in both cases, I ended up with the same number. So when their signs are different, subtract and keep the sign of the larger number. But when the signs are the same, you just add and keep their sign. Let me show you one other thing. So I'm going to add a variable into the mix. Let's say I have something like x plus 5, and I want to simplify that if x equals negative 8. So all I'm going to do is substitute for x, that negative 8. I'm going to take this negative 8. Since x is equal to negative 8, I'm just going to replace the x with negative 8. And now I can simplify this expression. Their signs are different, so I'm going to subtract. I start in negative land. I walk towards positive land. So I ended up at 3, but I didn't quite make it to positive land because 8 is bigger than 5. So I keep my negative number. You can always draw a number line to help you. That's okay to do. Let me do one more. What if I have 3 plus x and x equals a -4? I'm going to put in -4 everywhere I see an x. So I just replaced my x's with that -4. And you can put it in parentheses if you prefer, but just remember that this positive and that negative, that positive and that negative, the negativity where this wins, that negative wins there. So really I could rewrite that as 3 minus 4. And again, this negative, you know, without that parentheses or with, either way, that negative wins out. Now, 3 minus 4, so the signs are different. I start in positive land, but I actually make it into negative land, so I'm subtracting, I end up with 1. 4 is bigger, so I have a -1 minus 4. I'm in negative land now, and I'm going to walk further into negative land. So now, because their signs are the same, I'm going to add those two numbers. So -1 minus 4 is 5. I'm adding the two numbers, and then I just keep their sign. I started in negative land, and I walked further into negative land. So you can always use the number line to help you when you're simplifying or adding or subtracting integers. Or you can remember this rule that when the signs are different, you're going to subtract and keep the sign of the larger number. And when the signs are the same, we're going to add and keep the sign of the numbers. Let's use this adding and subtracting integers for various things. So the uppercase sigma, this symbol, this Greek letter, sigma, is used in mathematics, and it means summation. So what that tells me is that I'm to sum or add together all of my numbers, all my x values that are there in my data or whatever my pattern is that I'm looking at. So that symbol, this sigma, just means to add. So let's use that sigma to help us to, or that summation symbol to help us to add. So here we've been given some data. Our x values are 5, 7, 1, and 2. And now we're just going to simply add those values. So I'm just going to take 5 plus 7 plus 1 plus 2. So 5 plus 7 is 12, plus 1 is 13, plus 2 is 15. Notice all the signs were the same, so I'm just adding them together. So to sum all of my data is just equal to 15. Here's another example of it. I'm just going to find the sum of all of my data values. And here's a list of my data values. So I'm just going to add these together. So -3 plus a -1 plus a -5 plus 0 plus -1. Maybe we put those in parentheses. But remember that when we have a plus sign and then a minus sign, that negative sign wins out. It becomes a negative. So I could rewrite this as -3 minus 1 minus 5 plus 0 and then -1. So see how the signs stay with those numbers. Remember from adding and subtracting our integers that when their signs are the same, we are really just adding them. So here I have a -3 and a -1. That gives me a -4. And I keep the sign of that number. I'm in negative land and I stay in negative land. Again, their signs are the same, so I'm just going to add them. A -4 and a -5 makes a -9. And then plus 0 is still just -9. So then a -9 and a -1, their signs are the same. So I just add the numbers and I keep the sign. So I end up with a sum of -10. So when I add all my data values together, my sum of those values is equal to -10. So that summation symbol, don't be scared by it. It just means to add up those values. Sampling error is just the tendency for a statistic to not exactly match a parameter. So let's remember first, what is a statistic? So when I go out into my population and I gather data from a sample, and I've gathered all this data, and I take that data and I narrow it down to one number to represent the data. Something like an average, or maybe a proportion, or a percent. Once I've narrowed all my data down to one number and my data came from a sample, we call that a statistic. Whereas if I've collected data from my entire population and I narrow it down to that one number, that average or that percent, we call that a parameter. Now, most of the time we can't get a parameter. It's really hard to do to get data from the entire population. So most of the time we are just getting a sample or a statistic when we have that one number. So because of that, our sample that we've taken may not be exactly like the population. In fact, it's, that's hard to get something that's exact. So to find this sampling error, what we do is we take our statistic, the one number from our sample, and we would subtract the population parameter to get our error. So here's an example of that. Let's find the error. If we find a statistic is 43%, but in actuality, the one number to represent the data should have been 45%, or that parameter was 45%. By the way, this error may happen not from any, not that anybody's making a mistake or that they're doing anything devious. It just happens that your sample sometimes is not exactly the same as the population. So to find that, what we do is we take our statistic, that 43%, and we subtract the parameter of 45%. Now we saw earlier that when we have integers and their signs are different, we really just subtract the two numbers. So 45 minus 43 gives me 2. And then I keep the sign of the larger number, in this case 45. So I started in positive land, I walked towards negative land, and I actually made it to negative land because 45 was bigger. So my statistic is 2% less than my parameter. And it's really important that we put our statistic first and then the parameter so that we can see this -2 tells me that my statistic was too low. If it had been a +2, then I would know that my statistic was too high. But in this case, it's a -2 to let me know that my statistic's a little bit lower than the actual population. So there's my sampling error. Here's another example. Researchers want to determine the average height of men in the United States. The researchers measure the height of 1,000 men and find an average is 69 inches. So they have 1,000 different heights written down, but they've reduced those 1,000 numbers down to just 69 inches. One number, which is called since it's from a sample, it's called a statistic. If the actual average of the population is 68.8 inches, find the sampling error. This 68.8 inches is one number to represent the entire population. So this is the parameter. So in this case, here is my statistic, and this is my parameter. And I want to find the sampling error. All I do to find that sampling error is take my statistic and subtract my parameter. Their signs are different, so I really am going to subtract the two. Remember, when you subtract, you've got 69 point, and here's 68.8. Line up your decimals. put a 0 there, and then just subtract. I need 2 more tenths to get to that. And then maybe you borrowed from here to get there. So that is just equal to 2 tenths. In this case, the 69 is larger than the 68.8 and it's positive, so my answer is positive. My statistic was larger than the parameter. So my sampling error is 0.2. So that's how we can use adding and subtracting integers to help us to find that sampling error. Math made simple at Simpson Math. Thanks for watching.